educators, welcome to today's Maths Literacy Show, proudly brought to you by Macmillan. Today we have a special revision lesson on data handling and probability.
Question 1, and I'm sure it's taken from the Macmillan textbook. So, if you are a researcher for a marketing company that promotes the following list of new products, what target sample would you select for a survey to get unbiased feedback from the potential customers? So they're asking me what would be my target market that I would get unbiased. So let's look at this. Right, my first one is cold drinks. If I want to sell cold drinks, I'm creating a new cold drink and I want to go and survey people. Would I look at children? Yes, children drink cold drinks. Would I look at teenagers? Yes, teenagers drink the cold drinks. Young adults, adults over 50. I actually want to sample everybody because it's a cold drink. So anyone would actually be my answer in this case. So we are looking at absolutely anyone, or should I say also maybe everyone. Okay, so that will give me an unbiased. Let's look at the next one. If I wanted to do a sports drink, would I look at boys under 20? I think that we would have to maybe be a little bit more specific because boys under 20 include like 3-year-olds. And I don't think I would be looking at 3-year-old boys for a sports drink. But boys under 20, I'm going to go with yes, I would interview them. But maybe make that like teenagers. The same thing for girls under 20. Young men, they would drink sports drink. Young women, I'm sure they would too. Now my question is, men over 50, would I actually go to men over 50 for a sports drink? I don't think that I would actually interview men over 50 because usually they're not involved in sports. Maybe they go to the gym occasionally. So we could probably leave out the men over 50. Also, we're thinking about parents. Parents of boys and girls that are under 20, or teenagers that would buy the cold drinks, normally they are under 50. So I'm going to go with those are young men and young women. So women over 50, again, I would also leave those out. So in this case, we're not going to interview everyone, we're going to interview just the young. Then let's look at a health tea. Well, health tea, boys under 20, not going to be interested in health tea, neither the girls. Young men, possibly. Young women, definitely. Young men, I'm going to go with possibly. Men over 50, I would say that they definitely. I'm going to take away these young men. I don't think young men are going to be interested in health tea. So can you see how we would get unbiased information? Let's do the last one, and then you guys can have a bit of a break. I'm going to get something to drink because this has made me thirsty. So last one, we're looking at a slimming drink. So I'm hoping under 20s don't need slimming drink. Not sure about young men. Megan might have to help me. On occasion. Young women, definitely.
Yes.
Men over 50, I think that they might be interested. Okay. Women over 50, definitely. Okay. So I'm not really sure about the men. Kind of put a question mark next to the men. You decide. But the kind of thing, this is an answer that you can't really get wrong because you can motivate one way or the other. Let's do question 2. We're dealing from now with solutions from all, from the grade 10, chapter 18, and we've got the pages, etc., etc. You've got this all in the notes. So the question goes with, a class of 25 learners completed a maths literacy test and received the following marks out of 100. And then they give us all the marks, and whenever you get marks, whenever you get data, first thing you need to do is have a look at it. Is it in order? That's important. Sometimes the order goes down, sometimes the order goes across, but clearly I can see 274 and 246. There is no order. So the first thing I need to make a note of is that I might need to order it, and that will come up later in the show. So I just like to make a note that it is not in order. And what they've done is they've given us a frequency table. So draw up a frequency table for the test results. They've given us the class intervals. So is 0 to less than 10. So this is going to be to 9. 10 is included in my second one. So I'm going to make a note that my 10 is included there, my 20 is included there, just so that I don't forget. is it's important that you have consistency and you follow the instructions and what they've given you. So now we have to do this, and it's going to be a little bit of a challenge because we are going backwards and forwards. And I like to go in order, cross them out as you go. Don't look for the different numbers because you tend to leave out. So I'm going to cross them out as I go and put in my tally. So there was 2, then I've got 74. I'm going to have to just move the board down a little bit. So 74 is there. 35 fits in there. 37. 67. 67. Go back to 46. So all we're doing is checking that we've got the frequency. Let's see if I can move it up a little bit. Right, 48. 70. Now that's important to remember. Where does 70 go? 70 goes there, bigger than 70 and equal to 70. 81. 59. 49. So all we're doing is adding these each in. 49. 27. It's a whole lot easier if I don't have to move the board up. 96. No, need to move it again. 51. 've got the rest of it. 93. And you just got to go through this. It takes a while. But just go through it and just do it in a logical manner. 63, a logical manner, and you shouldn't have a problem. 54, 52, 98, and some nice marks for this test. 68, 53, 87, nearly done, 73, and lastly 80. And then all we need to do is work out what the frequency is. So how many is that? We've got 1, 0, 1, 2. Makes it easy for us to add up. 4, 5, 3, 3, 3, and 3. Then I tell my kids, always add this up. Get a total and check that we actually have every number in. So it's important that we check. So I'm just going to do that quickly. So 2, 4, 8, 13, 13 and 3, 16, 19, 22, 25. So we got 25. Double check that we started with 5 across 5 down, so 25. So I know I've got every number. So it's important. If you don't have every number, you're going to have to go back and check again. Answer the question. So which class interval has the greatest frequency? My class interval is one with a 5, so it is bigger than 50, and write it exactly the way it is, and less than 60. Can you read the actual marks that the learners achieved from the frequency table? Now, this is a really nice question. From the frequency table, we can see that we had 5 kids between 50 and 60, but we cannot see exactly what marks they got. So from a frequency table, when it's grouped, we cannot. And finally, would you describe the data collected as discrete or continuous? So let's quickly discuss what the difference between discrete and continuous. Discrete is we've got individual numbers. And continuous is when they continue, and usually they are grouped. They're usually grouped. We usually have numbers in between. So if we describe the data collected is my original raw data. That was discrete. If I look at what I have done since and my frequency table, well, that actually makes it continuous. It's important to answer what they've asked. And they said the data collected. So my data collected was in actual fact discrete. The next question comes again out of our Solutions for All. This is grade 10, same chapter, pages. We've got all of it, question 12. And in this case, they've given us a table with the tally. So we're looking at cell phone networks. Now, always, guys, I always like to analyze the table first and see what we're looking at before I even go on and read the questions. Make sure you understand the table. So we're looking at cell phone networks. We've got 4 different cell phone networks. We've got Blue Hibiscus, Green Cloud, AskTel, and Mobile Us. And then we're looking at comparing boys to girls. And from this, we've actually got a tally table. So we can add these up and work out how many in each network, each cell phone network, and whether they are boys or girls. The question says, draw up a frequency table to summarize the data from the tally table. So they've given us a frequency table, so let's go through it. So Blue Hibiscus, how many boys were there? Well, there was 13 boys. How many girls? Was 15. Can you see how easy it is to read when you've got it in fives? The next one is my Green Cloud. How many boys? There are no boys. And that in data handling is a hugely important number. Okay? It is not nothing, it is a 0. Really, really is an important number because it comes into all our central tendencies and everything that we do later on will uses that 0. It's an important value. Our frequency of green clouds for girls, okay, so we're going to add that up. It's 5, 10, 15, 20, 25, and 3 is 28. AskTel boys, 5, 10, 15, 20, 23. And the girls, you see how easy this is? 5, 10, 15, 20, 25. And lastly, we're looking at this Mobile Us. We've got 5, 10, 15, 20, 25, 30, 31. And the girls in this case was only 4. Right. Then we can use that information to answer the questions. So let's see what other questions they're asking us. Which is the most popular network overall? So to get our most popular network overall, we're going to need to add these values. So, we've got 28. I'm going to add them. 28. This one I've got 48. And there I've got 35. So which is my most popular? It is AskTel. Which is the most popular network amongst the boys? So now we go to our boys. Which was our most popular? Well, in this case, it was, the highest is Mobile Us. Which is the least popular, and it's important that we read the questions carefully. So the least popular network amongst the girls was the Mobile Us. Now, isn't that a very interesting statistic? What's most popular amongst the boys was the least popular amongst the girls. How many boys prefer Mobile Us to Blue Hibiscus? So we're looking at boys. We've got the Mobile Us. Let's go, that number was 31. And we want to know how many had Blue Hibiscus. Blue Hibiscus was 13. And we want to know how many boys prefer. So we're looking at the difference of the two. So I'm going to get my calculator out. I'm not sure if I can think about this now. Need a break, I think. 31 minus 13. And we get an answer of 18. So 18 boys prefer Mobile Us to the Blue Hibiscus. Okay? Or 31 compared to 13 that you prefer Mobile Us.
Okay guys, I hope you are enjoying this revision session. If you are struggling and need help, remember to post on the Facebook page, facebook.com/learnextra. Now it's time for a break, so don't go away. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on Facebook and on Twitter. Enough of the chat. Let's get back to revision.
A certain grade 12 mathematical literacy class wrote a test on probability. And these were the results. So we got 15, 80, 75, 77, 70. First thing I noticed, are they in order? No. So I need to order them. So that's what I'll look at first. Okay? How many students are in the class? Well, we're going to count the classes. So we've got 2, 4, 5, and the 3 rows. So there are 15 students in the class. Calculate the range. Remember, our range was our highest minus our lowest. So how are we going to do that? We're going to look at our values. There's my lowest, 15. And what's my highest? If I go through, I can see 80, and I can see an 83. So 83 is my highest. So this will be 83 minus 15. And you can get your calculator out. Is 68. What is the mode? Now we're looking at the mode, we're looking for something that occurs more often. So 15, there's 1 15. So if I look through these, I can see, let's use a different color. Right, I've got 75 occurring more than once. 80 only occurs once. And if you put these in order, it actually makes it easier to read. So let's do that quickly, because I'm sure we're going to need them in order. So let's put them into order first. So we've got our lowest was 15. Then our next value, and I'm going to cross that out. So I know that I've used it. My next values, I've got nothing in the 20s, nothing in the 30s, nothing in the 40s. Now, you can do this on a piece of scrap paper. You can use a, I'm sure that you might have learned how to use a stem and leaf to put them into order. I'm just going to do it by inspection. So my next one that I've got 60. Okay, I've got 60 again. And you see, all of a sudden, I'm seeing that there's another mode with 61. 62, and I've got no more 60s. Then I've got 75, I've got 70. Now I missed a 58, my 58 in there, and I've missed a 70. I'm doing well. So 70, I've missed my 58 was there. So 75, there's 1. There's 2, there's actually 3 75, so it is still my mode. I missed a 73. And you see how it ends up being a little bit messy. But guys, this is what it is. Okay? So then what you would do is you would actually rewrite it a little bit easier, a little bit neater. So I found my 63. Did I put in my 68? I left out my 68. Okay, clearly 77. The most important thing is then I've got an 80 and an 83. The most important thing is count the values that you have, and don't forget those zeros. So count them. Now I've got 2, 4, 6, 8, 10, 12, 14, 15. I've got 15, so I do have all the numbers. So it's important that we do that. Now from that, because it's in order, I can quite easily see that my mode was 75. There were 3 75s. Determine the mean or the average. Round your answer to 1 decimal place, if necessary. So what are we going to do? We're going to add them all up. So I get my calculator out, and I'm going to add them. So 15, and I'm going to do them in order, plus 58. And check that you are doing this. As you're doing that, you're not missing out numbers. 60 plus 61 plus 62 plus, yes, I'll have to move that over that side. 62 plus 68 plus my 70. Check that you're entering correctly. You don't want to do this twice. I actually suggest that you do this twice, that you actually check 75 plus 75. So if you get the same answer twice, then you're probably correct. Plus 80, and what was my last number? 83. And I'm going to get an answer. It's 992. Now, really, really, really important that you write that answer down. So when it comes to this, don't just give me an answer. And now I can't remember what it was. 992. So we're going to write that in. Our was 992. And we had 15 values, and we're going to get an answer. So take my answer, divide by 15, and I get 66,13. Remember, it asked me to go one decimal place, so 66,1. And remember, these were percentages, so you can actually add the units. Arrange the data in order and go on to show how you would find the median. So again, let's rewrite our numbers. Okay, I'm going to rewrite them here. In fact, maybe I won't rewrite them. I think we've got them here. 15, 58. I think I'm going to work with them up here because I don't want to move the board up and down. So I'm going to, in fact, I'm going to do this underneath. So I've got 15, 58, 60, just so that I've got all the numbers in. 60, 61, 62, 68, 70, 73, 75, 75, 75, 77, 80, and 83. Oh, maybe I need commas between them, so it's a little bit easier to read. Okay, now, how am I going to find my median? I'm going to count. If I've got 15 values, then I can start counting 1, 2, 3, 4, 5, 6, 7, 8. My 8th value from that side. I count from this side, 1, 2, 3, 4, 5, 6, 7, 8. So in fact, I might be able to move this down. Let's delete that. Okay, that works. So they're in order. And like I said to you, 15 values. So the 8th value, 1, 2, 3, 4, 5, 6, 7, 8. So it is 70. And just check that we've got 8 from the other side. So it's 1, 2, 3, 4, 5, 6, 7, 8. So 70 is my median. And you can do this. You can cross them off. Like I said, you can use your hands and you can actually decide something. You can count them. It all works. Now when you get to the middle number. Which of the averages, the mean, mode, or median, best describes the set of test results? And explain your reasoning by mentioning why you have decided on a particular average and why you don't think the other two averages are suitable to use when trying to give a full overview of the test results. They often ask this question: which is the best central tendency? Now, if we look at our information, my mode is 75. That just happens to be the one that most people have chosen. Okay, well, most people results. It was only 3 out of 15. It's not actually the best data. And that could have been 3. You know, what was our lowest? Our lowest were 15. We could have got 3 kids in the class that got 15. I can't say the entire class did badly in the test. So mode usually is not the best. Then I've got a choice between my mean and my median. Now, my mean was 66, and my median is 70. So which one of those best represents the information? And whenever they ask you this kind of question, your answer usually is the median, because why? It is as many learners, as many got below 70 as above. So it makes it a very good indicator of the center. Because there were 7 that got more than 70, there were 7 that got less than 70. So it makes it a very good indicator. My mean, on the other hand, is too low. It's too low. And usually that is because we have an outlier. An outlier is a piece of data that kind of doesn't fit in at all. Now, if we look at our numbers, look at our values, if I exclude my 15, my lowest is 58. That 15 is way lower than the rest of the class. We go from 58 to 83. So that is an outlier. It is totally outside the rest of the group, and it tends to skew the data. So it's too low. We've got an outlier, which makes it too low. So my answer to you is, whenever they ask you this question, it happens to be the median. And you can always say that your mean usually is skewed by outliers, your median is the best, as many above as below. So question 5 says, consider the following data about the population in different provinces of South Africa. I'm going to read this. I'm not sure how much I'm actually going to be able to get through, but then you guys can do it on your own. We're looking at the population of South Africa by province, 1996. I've got the Eastern Cape, I've got 6.3 million, Free State, Gauteng. Interesting, I've got Limpopo with just an A, which leads me to believe we're going to have to work that out. The Northern Cape, Northwest, and the Western Cape. So we've got all these big numbers. And this is the one thing about data, tends to be interesting numbers. Big numbers, kind of messy numbers. We don't normally deal with the simples. It's really nice. The mean or the average population for all 9 provinces is 4.5 million. What is the population of Limpopo? I'm going to show you how you would do this. I'm going to leave you to do it together. So if we add them all up and we divide by our 9, we're going to get our answer of 4,509,286. That's going to be my answer. Now, I don't have time to add them, I'm sure. I'm going to add the rest. So let's do this. I'm going to add these. Well, I'm not going to do it right now. You guys are going to do that. We're going to add these. I'm going to do it in blue. So if we had added them, now we don't have Limpopo. Limpopo was an A. That divided by 9 is equal to my 4.5 million. I'm going to leave it like that. So how would I work out the A? It's my addition plus my A is equal to this 4,509 million times my 9, because I've got to get rid of the 9 on its own. So, and I do that, I'm going to times the 9 and then finally minus what I added, and I'll end up with the A on its own. Hope that helps you guys. I'll give you a clue. And this is a nice kind of question that you will get in a paper 2 question, and it's really important that you know how to do it.
Now it's time for a break, so don't go away. We'll be right back. Welcome back from the break. Please let me know how your prelims are going. Guys, the end is in sight and your school careers are almost over. Don't give up now, push through, and remember that every little bit of extra effort will pay off. We believe in all of you, and that's why we're bringing you Spring School from the 23rd till the 27th of September, each day from 9 a.m. till 6 p.m. And don't worry if you miss anything, because we'll be repeating the day's programming from 8 p.m. each evening. Get all the details at learnextra.co.za/Spring School. But for now, let's get back to today's revision.
Over here on the left-hand side, we've got 2. We've got one on the left and one on the right. Let's just focus on this on the left-hand side. We can see here that we have graphs that look like little bars, okay? Now, because of that, we call that a bar graph. So let's write it here so we don't forget, a bar graph. Okay, now let me just explain what that graph's about. Basically, what happened is someone's gone and done a kind of survey, and they've gone to different households and said, how many of you have a radio in your home? How many homes have a computer? How many homes have TV? How many homes have a fridge? How many homes have a landline telephone? How many homes have internet? How many homes have cell phones? Okay, and they did that survey in 2 different years. The first year they did it was in 2001, and the next year they did it was in 2007. Now, folks, the reason we draw a bar graph, okay, is to work out or have a look at information pertaining to one specific year. So if you look here on this graph on the left-hand side, we're looking at the number of households that had radio, computer, or TV, fridge, landline, internet, or cell phone in their homes in 2001. On the right-hand side, we can see now that we're looking at the number of households that have radio, computer, TV, fridge, landline, internet, or cell phone in the year 2007. So we've got 2 different bits of information. And we'll draw single bars if we just want to focus in on 2001. So here, we just want interested in 2001. We're not worried about what happens in 2007. On the other side, we're focusing on 2007. We're not worried about what happens in 2001. Okay, so bar graphs, we're looking at specific information pertaining to 1 year or to one occurrence, as it were. Okay, now, could I make a comparison between the years 2001 and 2007? Maybe we want to know, well, have the number of households who had internet in 2001, has it grown since 2007? Well, of course we can make the comparison, and we have to make those comparisons. Can we use bar graphs to make those comparisons? Absolutely. We can look here at a bit of information, and then we can compare it to 2007. So in 2001, we got 73% of households had a radio. In 2007, 76.6% of households had a radio. Let's look at the internet. I find that one interesting. In 2001, no percentage of people had internet in their homes. But in 2007, we had 18.6% of people had internet in their homes. Right. So we can make that comparison. But what we're going to look at now is what happens if I take the information from 2001, I take the information from 2007, and I slap that information together in one graph. Look what happens. We now land up with graphs looking like this, and we're going to call this a double bar graph. Okay. And guys, the name actually helps you, hey? Double. You can see we've got two graphs, two graphs, two graphs. But if you look at the graph, you'll see that they are two different colors. We have this kind of funny green turquoise color, and that would be, I'm just going to call it green. Why? Because I don't know how to spell turquoise. Okay, so we got green, and we're going to say green represents the year 2001. Then we have this orange color, and hopefully that's what it looks like on your TV screen, and we're going to say orange represents the year 2007. And this bit of information saying the green represents 2001, orange represents 2007, we call that our key, K-E-Y. And guys, it's important to put a key down when we've got a double set of information. Otherwise, we're not going to know, well, what does green represent and what does the orange represent? So we've got to tell our examiners or our readers, guys, green means 2001. Orange means 2007. Now look how we've taken this information and we've put it together on the same graph. Why would I do that? I would do that to make the comparison between 2001 and 2007 and see if technology has advanced in those 6 years. So let's have a look at it. Radio has increased. Hasn't increased very much, but there has been an increase in the radio use from 2001 to 2007. Computer use has increased quite a bit. TV use has increased. Fridges, more people are using fridges. Okay. This is an interesting one, landline. Less people were using a landline in 2007 than what they were in 2001. Why do you think that was? Megan, why do you think?
You want me to tell you?
Yeah, do you know?
I think technology wasn't what it is. I don't think everyone
But there's been a decline in the number of people that are using landlines.
Oh, landlines.
Yeah, why?
Because we
'Cause
don't
look
need
at this.
them. We have cell phones.
Because more and more people are using cell phones. Okay, so cell phone usage has increased, and because of that, people saying, gee, I've got a cell phone, why do I need a landline? Okay, and internet has also increased. You'll notice here, let's have a look here, there is no green marking. Why? Because, according to our data, no one had internet in 2001. I don't know how true that actually is.
Oh, I was in grade 1, so I actually probably wouldn't even know.
Is it? That's kind of scary because, like, I was kind of old in 2001. All right. But in 2001, and guys, in fact, I must tell you, hey, I remember when internet first came into the world.
Really?
It was the weirdest thing. Okay? Because what actually happened was, I went to teach overseas, and I left at the end of 1999 just to teach in a bit of an American system and British system, see what that was about. And so off I went. And just before I went, there was a friend of mine at the airport who was absolutely devastated I was leaving. Okay? And there she was, sobbing her eyes out, and she gave me her address and said, "Here is my address," and gave it to me. And I didn't look at it, and I took it. I said, "Thanks very much," put it in my pocket. And we got on in the aeroplane, and I flew off, okay? And while I was flying in the air, I thought, "Oh, I must write this address down in my address book, otherwise I'm going to lose this piece of paper." And I took it out, and I thought, "Oh, shame. This girl is so devastated that I'm leaving. She's written absolute rubbish down."
Doesn't even make sense.
It made no sense. It said something like, I can't even remember what it was. Let's say abc@hotmail.com. And I thought, she hasn't even said what province, what code. This
South
woman's lost
Africa.
it. So I tore it up because it made no sense to me. Okay? So we've really developed quite a
Since
bit.
then.
And this data is showing us. Internet, we had nothing going in 2001. Oh, did you see that fly away? Okay, we had nothing going in 2001. In 2007, we had a lot more internet. Can you see how I've taken a bit of information and put them together to make a comparison? Now, there's another thing we can do with this information. Let's have a look here. I'm going to put my one bit of information on top of my other information. And we're going to call that now a compound bar graph. Okay, now viewers, I must just stress something. Okay. South Africa, the UK, and the American system. Depending what textbook you're looking at, some textbooks refer to this as a compound bar graph and refer to this as a double bar graph, and others do it the other way around. Okay. But we're going to call this a double one, and this bottom one here, we're going to call a compound bar graph. Now, why would I use a compound bar graph? Here we can see green represents 2001. Let's call that green. Green 2001, and we said our orange was 2007. Now, let's have a look at this. Why would we want to put information on top of each other? We would want to do that when we're more interested in the actual form of technology rather than who had the highest amount in what year. Okay, so here we're making a comparison between the different years, and for our compound bar graph, we're making a comparison not so much between the different years, although we can still see it, but we're making a comparison more between which form of technology or which appliance is being used more in the homes. So when we look at that, you can see straight away, hey, radio is the most popular appliance, the least popular, internet. Okay, whereas looking here, it's kind of hard to decide which one overall is the most popular. Whereas looking at our compound bar graph, it's so simple to see. Now we can put that information in another form of graph. Let's have a look at this. We've now got a line graph. And with our line graph, I'm really coughing here today. I don't know what's wrong with me here. In 2001, we can see we've got this information and we've made little dots on our graphs and we've connected those dots with lines. Hence, we call this a line graph. Okay. 2001, 2007. Okay. Two different bits of information. The one graph we'd look at if we're only interested in 2001. The other graph we're going to look at is if we're only interested in 2007. Can we put the two bits of information together? Absolutely. Let's have a look at this. There is a bit of the same graph again, but now it's in the form of lines, and you can see that we have two lines. Remember, our green represents 2001, and our orange line represents 2007. And folk, you can get that in an exam, okay? Now, just this morning, I was dealing with a student called Zanelli. And Zanelli, I hope you're watching this because I told you must watch because you're going to learn a lot from it. And we were going through past papers and we came across a question which actually had a double line graph. Okay? They didn't ask us to draw it, but they gave two on the same graph and asked us questions about it. So, folks, we were looking at how to represent data. We came up with this whole thing, and we could have bar graphs. We could have double bar graphs, which are still bars, but they're next to each other. We could have compound bar graphs, which are still bar graphs, but 2 bits of information above each other. Then we looked at line graphs, which is when we've plotted information as dots and then joined those dots with straight lines. And then just before the break, we said we could also get something called a pie chart. Okay, and this is what is known as a pie chart. Now, we've got 2001 information and 2007 information. Now, sorry, geez, I don't know what I've eaten today.
It's okay, it's fine.
So in 2001, you can see how many people use radio, computer, TV, fridge. You can't get the exact figures from it, though. Okay? It's quite hard to read it, but it gives you a basic understanding of everything that's going on here. So just by looking at that, you can see, well, in 2001, a lot of people used the radio, and not so many people had TV. Whereas if we look at 2007, we can see here that the percentage of everyone using radio has kind of decreased a little bit because all the other appliances have increased a little bit. So in other words, what a pie chart's doing, it's looking at all those appliances, and it's now saying, of all the appliances, what portion of it belongs to radio? Over here, what portion of that belongs to radio? Can I take my information from a pie chart or take 2 different bits of information and put it into one pie chart? Guys, I actually can't use a pie chart to make a comparison. Okay, that's the only huge downfall with this pie chart. I can't take information from 2001 and 2007 and put them into the same pie chart and try and make a kind of comparison between it. Well, we can't do it in Mathslit anyway. We don't even look at that. Okay, so, but what I can do, and this has come up in a past paper, if we look here, I've drawn 2 circles. Okay. And I'm just going to kind of, let's make up an example here, right? Let's say I've got tiny little beads. And I've got red beads, green beads, yellow beads, and blue beads. Okay? What I can say is I've got some green beads, and Megan, you've got green beads.
Okay.
Okay? We want to know how many green beads do you have and how many do I have. Now, this represents the total number of green beads. Now, we've seen a paper where an examiner has done something like this. And I'm going to try and draw a straight line, as straight as I possibly can. Let's have a look. And let's try to draw it again now. Okay, and then... And then we're going to do this. So now, what's this graph showing me? It's showing me the total number of red beans, blue beans, yellow beans, and green beans. And then I've got 2 lines coming off the green beans. So in other words, I'm saying this graph here, pie chart here, represents the full amount of green beans. It only shows green beans. But we're going to divide it again to show how many green beans Peter has and how many green beans Megan has. Okay? Guys, that came up in one of the past papers. It wasn't about beans, it was something else. But it's quite a complicated kind of question. Let's look at it again. So here we're showing the total number of green beans, and here we're dividing those green beans and saying these ones belong to Peter and these ones belong to Megan. The other thing we've got to remember about a pie chart, folk, is this, that there are 360 degrees in a circle. Got to remember that, and you'll see why later on when we do some examples. Okay, so we're going to go through all this again, but what we're now going to do, and there's just one other graph I've got to just quickly explain, because this does cause a bit of confusion, so let's have a look at it. This graph over here, we're going to call this a histogram. Oops, let's write it again, sorry.
It's okay.
My hand kind of
He hasn't been here
goes...
for 3 weeks, guys. We'll just accept.
Histogram. What is a histogram? A histogram has got like bars, but I don't like calling it bars, but they are like bar graphs, but the bars are touching each other. And it's talking about a continuous set of information. In other words, if we look at the bottom here, we've got something called time in minutes. I've got from 0 to 10 minutes, from 10 to 20 minutes, from 20 to 30 minutes, from 30 to 40 minutes, 40 to 50 minutes, 50 to 60, and then this is a amount above 60 minutes. All right, so it's time. Now, if we look here, we can see that we've got around about 11 and a half people, and I'm just going to make up a story what this graph represents, because I don't know what the real question was. But we could say that guys are sitting down, they're going to write a quick maths lit test, okay? 11 people finish, so it can't be 11 and a half, because you can't have half a person, even if their brain is a little bit funny. Okay, so we got 11 people who finished the test within 10 seconds. We don't know if they did it in 1 second, 2 seconds, 3 seconds, 4, but we know from 0 to 10 minutes, rather, not seconds, they completed the test. From 10 to 20 minutes. So we now had 22 people who finished this test between 10 and 20 minutes. It could have been 10,5. It could have been 19,5 minutes. Okay? It could have been 19 minutes, 59 seconds. But that graph is showing us how many people finished their test within a specific period. It's not telling us exactly what time they finished it. It's giving us a range of time. So we tend to use histograms when we've got a range of data, okay? And it can be in minutes, it can be height, it can be in kilometers, it can be people's weight, okay? But it's continuous data. This is all minutes. Before, we had yellow, red, green. Okay? Here we've got all the minutes. All right? Do you understand what a histogram is? So a histogram is looking at a set of data. All right? And each bar represents a certain range of that data. We're going to look at a few questions which involve some of these charts, okay? So I have a bar chart here, and let's read this. Mrs. Smith, a quality controller for a toothpaste manufacturer, inspected 400 tubes of toothpaste. This comes from a matric pass paper, by the way, okay? The number of faults of different types is recorded in the graph below. So what actually happens is this. We've got someone who's doing a quality control, okay? They're checking all the toothpaste that come past her. And 400 come past. And of the 400, she notices that 12 of them have a specific fault. And we're going to call it fault A. Now, that fault A could mean anything. Maybe it means the lid isn't screwed on properly. Okay? We've got 6, which are fault B. Okay? What does fault B mean? Well, we're not sure. Maybe it means the base of the toothpaste is not closed, sealed properly, and so a little bit of toothpaste is oozing out. We've got here 2 with fault C. Fault C could mean maybe there's not enough toothpaste in the tube, and so the tube's looking all funny. All right? We've got 2 with fault D. I don't know what fault D could be, but there's some fault. And E, we've got 1 fault. All right. So looking at that, we can see now what's our major problem? Our major problem in manufacture is fault A. And what did we say fault A was? We made it up. We said the caps aren't screwed on properly. Okay. Which is the least of our problems? Fault E. Now, let's see the kind of questions that came up about this. First of all, what was the total number of faults found in the 400 tubes of toothpaste? Okay, so remember, 400 tubes came past, and we found 12 faults, 6 faults, 2 faults, 2 faults, 1 fault. What's that going to give me? 12, 18, 20, 22, 23 faults. So that's quite a lot of faults when you think there are only 400 that we're looking at. Okay, so my answer here is there are 23 faults. Next one. The company wants to improve its product by reducing the number of faulty tubes it makes. Which one of the fault types should be fixed to give the greatest improvement? Okay, well, obviously, folk, A, we got a huge problem here. If we can fix up A, we got 12 of our problems gone. That's fantastic. If we fix up B, we've only lost 6 problems. C, we've lost 2. D, we've lost 2 problems. E, we've lost 1 problem. So if I can work on fault A, hey, we're on to a winning streak here. Okay, next one. Oh, so it's going to be fault A. Next one. A tube of toothpaste is chosen at random from the sample of 400. Okay, so 400 toothpaste come past, we just grab one. Close our eyes, grab it. Okay. Now, what's the probability that the following will be chosen? Now, folk, look at this. From looking at bar graphs, we're focusing on bar graphs. Suddenly, there's a probability question that comes out of it. And that's the great thing about MathSlit, isn't it? That we can overlap all our different sections of work. Okay. Not like that horrible subject, maths. Maths, if you're doing factorizing, you're factorizing. If you're doing simplification, you're simplifying. If you're doing, I don't know, trigonometry, you're doing trigonometry. But MathSlit, we take all the topics and we mix them up because that's what real life's really all about, isn't it? So, what's the probability that we will take a fault B? Now, remember, there are 400 toothpaste tubes. So out of the 400, how many had fault B? So let's have a look at it. 6 of them had fault B. So we've got 6 out of 400 that had a problem. Okay, and when we simplify that, we're going to get 3 out of 200. Here's a good one. How many, okay, what's the probability that we grab a tube of toothpaste and it has no fault at all? Well, let's have a look at this. No fault at all. Now, we know there are 400 tubes of toothpaste. How many of them have a fault? There are 23 that have a fault. So if there are 23 that have a fault, how many of them don't have a fault? Okay, well, we're going to say it's 400 minus 23. And 400 minus 23 is going to give us, what's it going to give us? 377, hey? 377 over 400. That's the probability of choosing a toothpaste, okay, that doesn't have a problem with it. Now, folk, they haven't told us how they want the answer. And you know, when you go to probability, you can write it as a decimal fraction, as a common fraction, or as a percentage. This question hasn't told us how to write it out, so we could just leave our answer as 3 over 200 and 377 over 400.
We've come to the end of today's show. Thanks to Macmillan for making the show possible, and thank you for joining us and for participating in this revision session. Remember to visit our website, learnextra.co.za/live to get the notes and to watch the videos. If you are stuck on any questions, make sure you post them on Helpdesk at learnextra.co.za/helpdesk. Don't forget to join us for Spring School starting on Monday the 23rd of September at 9 a.m. See you then.